चैंपियन कोर्स किन के लिए है? जो IIT JEE एडवांस का एग्जाम दे रहे हैं, मेंस का एग्जाम दे रहे हैं, उनके लिए है। ये कैसे ज्वाइन कर सकते हैं? आपको यूट्यूब चैनल पे जाना है, वहाँ पे ज्वाइन बटन है, मेंबरशिप लेना है यूट्यूब का। आप मेंबरशिप लोगे तो मैं इस कोर्स को ज्वाइन कर सकते हो। इसमें आपको पूरा कोर्स करवाया जाएगा, आपका लाइव डिस्कशन होगा, DP दी जाएगी, यानी पूरे ऑर्गेनिक केमिस्ट्री की कोर्स की गारंटी अच्छे से करवानी आपको सिखाने की मेरी होगी। तो आप ज्वाइन कर सकते हैं यूट्यूब के मेंबरशिप प्रोग्राम के थ्रू। ज्वाइन बटन पे क्लिक। हेलो, now today we are going to study the flipping in cyclohexane. Now let's start with the conformer, and now we will going to discuss the flipping in cyclohexane. Flipping, or you can say inversion in cyclohexane. Initially this is the chair form of cyclohexane. At room temperature it undergo flip. Now what is the meaning of flip and how this process is going on? At room temperature, if we move this carbon slightly up, now this chair will convert into half chair. If you move this bond up, the chair will convert into half chair. Now again, if we move this carbon up, this half chair will convert into boat form. And boat is our unstable form. Why it is unstable? I will explain you later. Now first of all, pull this carbon up, it will convert into half chain. Then pull again up, it will convert into boat. Then pull this carbon down, it will convert into half chair. Again pull this carbon down, it will convert into chair. In that way, the one chair convert into another chair. Now this interconversion is known as flipping, or it is also known as inversion. Now let me explain the same concept with using this model. You can zoom the video. This is our chair form. This is our chair form. Now what I am doing, I am pulling this carbon slightly up. This is half chair. Again up. This is our boat form, boat. Now after forming boat, we have two options to form different chair form. If I pull this carbon down, it is half chair. Again down, it is another chair. Now let me explain once again. It is chair form. Pull this up, half chair, again up. This is our boat. Then pull this carbon down, down. It will convert into chair. In that way, one chair convert into another chair. Now this boat is unstable. If we compare stability of chair and boat, boat is unstable. Now why this boat is unstable? Because of flagpole hydrogen repulsion. Now what is the meaning of this flagpole hydrogen repulsion? Flagpole hydrogen, as the name suggests, flagpole means just like a flag. Now in this diagram we can explain the flagpole hydrogen repulsion just like this. This type of repulsion is known as flagpole hydrogen repulsion. Now why it is known as hydrogen repulsion? Because of 2 HH. Why it is known as flagpole? It seems to be a flag, just like a flag, flagpole repulsions. So that's why boat is unstable. So first of all, write this flipping in your class notes. Now there is a second concept. There is a flip. What is the effect of flipping? If there is a flipping, whenever there is a flipping, equatorial bond flip into axial bond, and axial bond will flip into equatorial. Now in this example, initially the methyl is in equatorial position. If it undergo flip, after flip it will convert into axial conformer. Suppose there are two equatorial positions of methyl, both will convert into axial. E flip to A, equatorial flip to axial, and axial will flip to equatorial. Now how it is going on, I will explain with you with the models. Now if this flipping takes place, equatorial to axial, and if I have to write the K equilibrium, what is the K equilibrium? The concentration of this axial divided by concentration of this equatorial. Now in this case, equatorial is more stable. This means this equilibrium is in backward direction. And if it is in backward direction, this means K equilibrium is less than 1. Got it? Now let me explain one more example. This is our axial form, and as we know, A flip into E. If it undergoing flipping, axial convert into equatorial. Now we have to write the K equilibrium value. What is the K equilibrium? The concentration of product upon concentration of reactant. And what is the direction of equilibrium? Now which one is more stable, axial or equatorial? Equatorial is more, this is more stable. Now this is more stable means direction of equilibrium will be in forward direction. Similarly, last example, it is chair form converting to another chair form, both are of same stability. In that case, equilibrium is equal to 1. Now in second, equilibrium is in forward direction. Therefore, K equilibrium is greater than 1. Now there are 3 different cases. If equilibrium is in backward direction, K equilibrium less than 1. Equilibrium forward direction, K equilibrium greater than 1. If both are of same stability, K equilibrium equal to 1. So first of all, write down your notes, then I will explain you how this axial convert into equatorial. Pause the video and write in your class notes. Now, let me explain with the model. In this model, this color blue is our axial position and white is our equatorial. White is at equatorial. Just remember white at equatorial. When we do flipping of cyclohexane, what exactly happen? First of all, it convert into boat form, and then boat convert into half chair and chair. Then pull this carbon down. Now what is the position? Now the white is at axial. Watch again. White is at equatorial. I am doing flipping. Again white equatorial. And after flip, white goes to axial. Means all equatorial convert into axial, all axial position convert into equatorial. Why this is happening? Now you can easily understand by this. Let us explain by my fingers. This is our axial position and this is our equatorial position. When we do flipping, what exactly happened to this carbon? This carbon goes down. This is flipping. If at axial position, after flip, it convert into equatorial. This is known as flip. You got it? So just remember it. Whenever there is a flipping, all axial bond convert into equatorial and all equatorial convert into axial. Now, this is the stability order. While flipping, the stability order is when we do flipping of chair, chair convert into half chair, then twist boat, then boat, again twist boat to half chair and chair. From this diagram, it is clear that relative stability is chair, most stable is chair, then our twist boat, then half chair. This is the relative stability. I will explain this using the model. First of all, you should just write down this energy diagram and account and relative stability. Chair more stable than twist boat, then half chair. Write down your class notes. I will explain this using model. Now let me explain the stability. Now first of all, I will explain you the flagpole repulsion. This is our boat form. This model represents boat conformer, and this is a flagpole repulsion. You heard the sound? The sound is very less because of small size of hydrogen. This is our boat form, and this represent flagpole repulsion. Got it? Now, why half chair is unstable? If I convert this boat into half chair, if you closely watch this model, you will find that these 5 carbon are in same plane. Basically, 5 carbon eclipsing takes place. This HH is parallel, this is parallel, this is parallel, this is parallel. There is a eclipse conformer of 5 carbon. 1, 2, 3, 4, 5. That's why half chair is unstable. When we convert half chair into boat, now how many hydrogen are eclipsing? These 2 and these 2, means 4 hydrogen undergoing eclipsing. In half chair, 5 hydrogen undergoing eclipsing, which means which is more stable, boat or half chair? Boat is more stable. You may have one question in your mind. In boat, there is a flagpole repulsion. Why are you not considering flagpole repulsion? Means why we are not considering flagpole repulsion. If you closely watch this flip, this hydrogen is doing eclipsing with this and this, means there are 2 eclipsing with this hydrogen. When we convert into boat form, both eclipsing will decrease. Means repulsion between 2 decreases and 1 repulsion increases. Here we have 2 repulsion, 1 and 2. In boat, only 1 repulsion. That's why stability will increase. Now this is known as our boat form. Now what is the twist boat and how to draw it? Now let me explain you twist boat. This is the structure of twist boat. Now why twist boat is more stable? If we check stability, in half chair, how many hydrogen are eclipsing? I already explained you, there is in half chair 5 hydrogen are eclipsing. In boat, 4 hydrogen are eclipsing. In chair, all are staggered, no eclipsing. Now, if we compare stability of boat and twist boat, so what is the difference between relative stability? You just check it. This is boat form. Now I will convert this boat into twist boat. Watch it closely and how stability increases. This is boat, this is twist boat. Boat, twist boat. Now, why stability increases? If you watch, the eclipsing between 2 hydrogen will decrease. Got it? Eclipsing between 2 hydrogen will decrease. Eclipsing decreases. Flagpole hydrogen repulsion decreases. Flagpole repulsion decreases, and these hydrogen eclipsing decreases. That's why twist boat is more stable than boat conformer. Got it? Due to twisting, if you want to write, then write twist boat is more stable. Because of twisting, the eclipsing of hydrogen will decrease. Because of twisting, eclipsing of hydrogen will decrease. Now let us check these data, explain why at 25 degree this axial flip to equatorial. If R is replaced by H, the K equilibrium value will be 1. In methyl it is 18, ethyl 21, isopropyl 35, and this is 300. Explain why. And then you have to explain if R equal to F, K equilibrium 1.5, 2.4, Br 2.2, and iodine 2.2. Why? Write the question in your notebook and just think why, how can we explain these data? Now in first case, since we know that which is more stable conformer, equatorial is more stable. This means as the van der Waals radii of axial increases, there is a 1,3 diaxial interaction. This repulsion will increase. This means it will convert into equatorial form. So basically, as the van der Waals radii increases, it becomes unstable. Now we can easily see that as carbon increases, from this to this, steric hindrance increases. As steric hindrance increases, K equilibrium will shift to forward direction. Now, can you explain what is the percentage of equatorial and axial conformer? What is the percentage of equatorial? If K equilibrium value is 18, what will be the percentage of conformer at equatorial position? Now, we know that data is 18. Now, it is a simple calculation. 18 means 18 by 1. This ratio is of E by A. Got it? Now, what is the percentage of E? Percentage of E equal to 18 upon total into 100. 18 upon total into 100 means it is nearly 95%. This is our percentage of equatorial conformer. So, just write down, as the steric hindrance increases, K equilibrium value will increase. Now, what is the reason of this in second one? When we move from fluorine to chlorine, K equilibrium increases. Now, we can easily understand by this because of increase in size. But why in case of chlorine to bromine, 2.4 to 2.2, it is decreases? Why it is decreases? And in case of bromine to iodine, it is constant. Now, this can be explained by Newman projection. This is our Newman projection. Suppose the chlorine is there. This will be the van der Waals radii. If I replace chlorine by bromine, what happens? The bond length of bromine will increase. Bond length will increases. So initially chlorine is here, bromine is bigger size, but its bond length will increase. You got my point? I will explain better in this way. This is our Newman projection of cyclohexane. This is our fluorine. Now, what happened? This is our chlorine. This is the van der Waals radii of chlorine. What we are expecting, that if we replace chlorine by bromine, the van der Waals radii will increase and more will be the repulsions. No doubt, van der Waals radii of bromine will increase because in the down the group size increases. But along with the size, bond length will also increase. Bond length increases. Now, due to increase in bond length, this steric repulsion is, you can say, nullify. Yeah, you can say from data, steric repulsion decreases. Now, we can go to data 2.4 to 2.2. This means that the bond length is dominating, it is away from H, means steric repulsion will decrease. Now, we can also explain this data, why it is constant. In bromine to iodine, it is constant. Now, you can see that if iodine size is increases, in same ratio, there may be increase in bond length. The increase in steric hindrance and bond length nullify the effect of steric factor. Got it? Means in single word, these data can be explained by bond length. Got it? Now, that's all for cyclic conformer. Hopefully, you have find very useful. After that, we will also discuss some DPPs. You have to watch this lecture very carefully and you have to prepare notes. And if you want to ask me, you can ask me in comment box. Thank you. Have a nice day.